Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to Al Munir High School e-learning system, class 9. This is your chemistry lecture. Unit number is 1. This is title page of your chemistry book for class 9. Yes students, today we are going to start our unit chapter number 1. The topic is fundamentals of chemistry. Its major concepts are branches of chemistry, basic definitions, chemical species, Avocados number and mole, and chemical calculations in the end. So first of all, we will start with the introduction of chapter number 1. The knowledge that provides understanding of this world and how it works is called the science. This is the definition of science. Next we have the definition of chemistry. What is chemistry? The branch of science which deals with the composition, structure, properties and reactions of matter is called chemistry. So what are the different uses of chemistry? The development of science and technology has provided us a lot of facilities in daily life. Imagine the role and importance of petrochemicals products, medicines, drugs, soap, detergents, paper, plastics, paints, pigments, insecticides and pesticides. All are these products are the fruits of the efforts of chemists. So the development of chemical industry has also generated toxic waste, contaminated water and polluted air around us. On the other hand, chemistry also provides knowledge and techniques to improve our health and environment and to explore and to conserve the natural resources. Next students, we have some branches of chemistry. Yes, here some branches are given. First of all, physical chemistry. Look at the definition of physical chemistry. What is physical chemistry? It is a branch of chemistry that deals with the relationship between the composition and physical properties of matter along with the change in them. So the properties such as structure of atom or formation of molecules, behavior of gases, liquid and solids, and the study of the effects of temperature or radiation on matter we will discuss in physical chemistry. Next, organic chemistry. What is organic chemistry? Yes, it is a study of covalent compounds of carbon and hydrogen. We call it hydrocarbons and their derivatives. This is also very important because some organic compounds occur naturally, some are synthesized in the laboratories. These are important. This branch is very important because it covers petroleum, petrochemicals and pharmaceutical industries. In organic chemistry deals with the study of all elements and their compounds except those of compounds of carbon and hydrogen. We call it hydrocarbons and their derivatives. So in this branch, yes, it will cover the chemical industries such as glass, cement, ceramics and metrology, which means extraction of metals from ores. Next we have biochemistry. It is a branch of chemistry in which we study the structure, composition and chemical reaction of substances found in living organisms like plants, animals, human beings. It covers all the chemical processes taking place in living organisms such as synthesis of and metabolism of micromolecules like carbohydrate, proteins and fats. Next we have industrial chemistry, the branch of chemistry that deals with the manufacturing of chemical compounds on commercial scale. So as the name shows, in industrial chemistry we will deal with the manufacturing of chemical compounds. It deals with the manufacturing of basic chemicals like oxygen, chlorine, ammonia, caustic soda, etc. Nuclear chemistry, yes, it is a branch of chemistry that deals with the radioactivity, nuclear processes and properties. The main concern of this branch is with the atomic energy and its use in our daily life. It also includes the study of chemical effects resulting from the absorption of radiation within plants, animals and other materials. Environmental chemistry, yes students, look at the definition of environmental chemistry. As the name shows, it deals with the components of the environment and the effects of human activities on the environment like environmental pollution, and it is also related with the other branches like biology, geology, ecology, soil and water. Analytical chemistry, yes, it is a branch of chemistry that deals with the separation and analysis of a sample to identify its components. So if we have some sample, so in this branch we will separate and analysis that sample. The separation is carried out prior to qualitative and quantitative analysis. Qualitative analysis provides the identity of the substance, composition. On the other hand, quantitative analysis determines the amount of each component present in the sample. Next, we have some test yourself questions. In which branch of chemistry behavior of gases and liquids is studied? Yes. Define biochemistry. Which branch of chemistry deals with the preparation of paints and paper? Yes. In which branch of chemistry are the metabolic processes? Answer is biochemistry. Yes. Which branch of chemistry deals with the atomic energy, nuclear energy? Answer is nuclear energy. Which branch of chemistry deals with the structure and properties of naturally occurring molecules? Yes, it is about the organic chemistry. Next, we have, students, some important concepts about matter. Yes, all of us knows about the definition of matter. What is matter? Anything that has mass and occupies space is called the matter. Yes, matter is found in three states: solid, liquid and gas. What is a substance? A piece of matter in pure form is known as substance. Every substance has a fixed composition and specific properties. What is impure matter? Yes, impure matter is called the mixture. Mixtures can be homogeneous and heterogeneous in its composition. Next, he is telling you about the physical properties and chemical properties, as we have studied in class 7 and 8, that physical properties are associated with the physical state of a matter, like its color, smell, taste, hardness, shape, solubility, melting and boiling points indicates the physical properties. Chemical properties depend upon the composition of the substance. For example, decomposition of water is a chemical change as it produces hydrogen and oxygen. So this chart represents the matter and its types: mixture and substance. Mixtures can be homogeneous, heterogeneous. Substances divided into elements and compounds. Now students, look at the definition of elements. What is element? Modern definition of element is that if it is a substance made up of same type of atoms having same atomic number, and it cannot be decomposed into simple substances by ordinary chemical means. So it is the definition of element. What is an element? It is a substance which is made up of same type of elements having same atomic number but cannot be decomposed into simple substances by ordinary chemical means. It means that each element is made up of a unique type. Most of the elements occur naturally in free or combined form. All the naturally occurring elements found in the world have different percentage in the earth crust. This table 1.1 shows natural occurrence in percentage by weight. Oxygen is 47%, silicon is 28%, aluminium is 7.8%, oxygen is 86%, hydrogen is 11%, chlorine is 1.8%, nitrogen 78%, oxygen 21%, and argon is 0.9%. Elements may be solid, liquid or gas. Majority of elements exist as solids like sodium, copper, zinc. Few elements occur in liquid state like mercury and bromine, and a few elements exist in the form of gases like nitrogen, oxygen, chlorine. Next students, what are the symbols? The elements are presented by the symbols, which are abbreviations for the name of elements. A symbol is taken from the name of that element in English, Latin, Greek or German language. If it is one letter, it will be capital, as for hydrogen symbol is H. For nitrogen it is N. For carbon it is C. In case of two letter symbol, only first letter is capital, like as calcium symbol is Ca, sodium symbol is Na, for chlorine symbol is Cl. What is valency? The unique property of an element is called valency. It is the combining capacity of an element with other elements, and it depends upon the number of electrons in the outermost shell. So look here, we have covalent compounds. Simple Covalent compounds, valency is the number of hydrogen atoms which combine with one atom of that element, or the number of bonds formed by one atom of that element. So here we have the examples: the valency of chlorine, oxygen, nitrogen and carbon. In simple ionic compounds, valency is the number of electrons gained or lost by an element. So whenever elements bound with each other, they come closer with each other, they gain or lose electrons from its outermost shell to complete its octet. Elements having less than 4 electrons in their valence shell prefer to lose electrons to complete their octet. For example, here we have the example of sodium, magnesium, aluminium, which have 1, 2 and 3 electrons in their valence shells respectively. They lose these electrons to have valency 1, 2, 3 respectively. On the other hand, we have elements which have 5 or more than 5 electrons in their valence shell gain electrons to complete their octet. For example, nitrogen, oxygen, chlorine, 5, 6 and 7 electrons in their valence shells, outermost shells. They gain 3, 2 and 1 electrons respectively to complete their octet. Students, here we have the table 1.2 which shows different elements, their symbols and their valencies. You have to learn this table and remember it properly. Some elements show more than one valency, they have variable valency. For example, ferrous sulfate FeSO4, the valency of iron is 2. In ferric sulfate Fe2SO4 whole 3, the valency of iron is 3. Next we have the definition of compound. What is compound? Compound is a substance made up of 2 or more elements. जब 2 or more elements आपस में मिलते हैं, they form a compound. They chemically combine in a fixed ratio by mass. As a result of this combination, elements lose their own properties and produce a new substance. Compounds cannot be broken down into its constituent elements by simple physical methods. We have the example of carbon dioxide. Is formed when elements of carbon and oxygen combine chemically within a fixed ratio of 12:32 or 3:8 by mass. Water is also example of a compound. Compounds can be classified as ionic compounds and covalent compounds. Ionic compounds do not exist in independent molecular form. ये आज़ाद हालत में नहीं पाए जाते molecular form में. They form a 3-dimensional crystal lattice in which each ion is surrounded by oppositely charged ion, plus and minus. These oppositely charged ions attract each other very strongly. As a result, ionic compounds have high melting and boiling points. In case of covalent compounds mostly exist in molecular form. A molecule is a true representative of the covalent compound. Its formula is called the molecular formula. For example, H2O, HCl, H2SO4 and CH4. And the formula of ionic compound is called the formula units. Here we have the examples NaCl, KBr and CuSO4. Now students, we have this table which shows different compounds and their chemical formulas. You have to learn and remember all these formulas. Next we have the definition of a mixture. When 2 or more elements or compounds mix up physically without any fixed ratio, they form a mixture. So this is the definition of a mixture. When 2 or more elements or compounds mix up physically without any chemical reaction, they form a mixture. So mixture can be separated into parent components by physical methods. What are these physical methods? Yes, we have discussed these physical methods in our previous classes of distillation, filtration, evaporation, crystallization and magnetization. Mixtures that have uniform composition, जिनकी एक जैसी composition होती है mixtures की, they are called as homogeneous mixture. For example, air, gasoline, ice cream. Whereas heterogeneous mixtures are those in which composition are not uniform. ऐसे mixtures जिनकी composition uniform नहीं होती, एक जैसी नहीं होती throughout, they are called heterogeneous mixtures. For example, soil, rock and wood. Next students, we have important information about air is a mixture of all these gases, soil is a mixture of all these things, milk is a mixture of all these things, brass is a metal which is a mixture of copper and zinc metals. Next we have comparison or difference between compound and a mixture. Look at it. First point, compound, it is formed by a chemical combination of atoms of the element. Mixture, yes, it is formed by the simple mixing up of substances. Part 2, the constituents lose their identity to form a new substance in case of compounds. In case of mixture, mixture shows the properties of the constituents. Number 3, compounds always have fixed composition by mass, and in case of mixtures they do not have fixed composition. In case of compounds, the components can not be separated by physical means, but opposite, mixtures are opposite, their components can be separated by simple physical methods. Every compound is represented by a chemical formula, and mixture, in case of mixture, they do not have any chemical formula. Compounds have homogeneous composition, and mixture, they may be homogeneous or heterogeneous in composition. Compounds have sharp and fixed melting point, and mixtures do not have sharp and fixed melting points. Next, students, we have definitions of atomic number and mass number. Atomic number of an element is equal to the number of protons present in the nucleus of its atoms, and it is represented by Z. As all atoms of an element have the same number of protons in their nuclei, so they have the same atomic number. Next, what is mass number? Yes, it is the sum of number of protons and neutrons present in the nucleus of an atom, and it is represented by A. So it is the addition of number of protons and neutrons. Here we have this table which shows different elements and their number of protons, number of neutrons. Atomic number will be the same as the number of protons, 1 1 6 6 7 7, but the mass number is the combination of both, yes, protons and neutrons. Next we have the example, how many protons and neutrons are there in an atom? Yes, A is equal to 238 and Z is equal to 92. First of all, develop data from the given statement. A is 238 which is given, Z is 92 which is also given. So students, what is A and Z? You have to remember it. Yes, the mass number is A and Z is the atomic number. So Z is the atomic number and A is the mass number. So here it is our mass number, Z is our atomic number. We have to calculate the number of protons and neutrons. So number of protons is equal to 92 and number of neutrons, A minus Z, 238 minus 92, which is 146. Now what is relative atomic mass and relative atomic mass unit? Look at its definitions. As we know that the mass of an atom is too small to be determined practically. However, certain instruments enable us to determine the ratio of the atomic masses of various elements to that of carbon 12 atoms. So here we have this tool to find out the relative atomic mass, which is carbon 12 atoms. So this ratio is known as the relative atomic mass of the element. We define the relative atomic mass of an element is the average mass of an atom of that element as compared to 1 over 12th the mass of an atom of carbon 12 isotope based on carbon 12 standard. What is atomic mass unit? When we compare atomic masses of other elements with carbon 12 atoms, they are expressed as relative atomic masses of those elements. The unit for relative atomic masses is called atomic mass unit. So with symbol AMU, atomic mass unit. AMU stands for atomic mass unit. One atomic mass unit is 1 over 12 the mass 1 atom of carbon 12. When this atomic mass unit is expressed in grams, so one atomic mass unit will be equal to 1.66 into 10 with power minus 24 grams. You have to remember this value for your numerical type questions. So mass of proton is given, mass of neutron is given, and mass of an electron is given. How we can write a chemical formula, students? Here some steps are given. Look at these steps. Symbol of two elements are written side by side as I have explained you in class 8. The valency of each ion is written on the right top corner of its symbol, like Na plus, Ca plus 2. These are the valencies. This valency of each ion is brought to the lower right corner of other ion by cross exchange. Look here, we will cross exchange it, Na plus, Cl minus. These are the examples. Point number 4, if the valencies are the same, अगर valencies एक जैसी हों, they are offset and not written in the chemical formula. But if they are different, अगर वो मुख्तलिफ होंगी, they are indicated as such at the same position. So in case of sodium chloride, NaCl, both the valencies are offset and formula is written as NaCl. But in case of calcium chloride, it is represented as CaCl2. Number 5, if an ion is combination of 2 or more atoms, which is called a radical bearing net charge on it. For example, SO4 minus 2 sulfate, PO4 minus 3 phosphate, then the net charge represents the valency of the radical. The chemical formula of such compounds is written as explained in part 3 and 4 above. What is empirical formulas? Yes students, chemical formula are of two types. Simplest is the empirical formula. It is the simplest whole number ratio of atoms present in a compound. The empirical formula of a compound is determined by knowing the percentage composition of a compound. The covalent compound silica sand has simplest ratio 1:2 of silicon and oxygen. Therefore, their empirical formula is SiO2. This is example of empirical formula. So as we discussed earlier, the ionic compounds exist in three-dimensional network. Each ion is surrounded by oppositely charged ions in such a way to form a electrically neutral compound. So what is formula unit? The simplest unit taken as representative of an ionic compound is called formula unit. It is defined as the simplest whole number ratio of ions as present in the ionic compound, or in other words, ionic compounds have only empirical formulas. Next we have molecular formula. Yes, molecules are formed by the combination of atoms. Yes, we know about it. These molecules are represented by molecular formulae that show actual number of atoms of each element present in a molecule of that compound. So molecular formula is derived from the empirical formula, where n is equal to 1, 2, 3 and so on. Here we have the example, benzene. The molecular formula for benzene is C6H6, which is derived from the empirical formula CH, where the value of n is 6. So here we have this table which shows the different compounds and their empirical and molecular formulas. Next, what is molecular mass and molecular formula? The sum of atomic masses of all the atoms present in one molecule of a molecular substance. It is its molecular mass. For example, molecular mass of chlorine is 71.0 atomic mass unit. Of water H2O is 18 AMU, and that of carbon dioxide is 44 AMU. We can calculate it. Now calculate the molecular formula of nitric acid. Yes, atomic mass of hydrogen is 1 AMU, nitrogen is 14 AMU, oxygen is 16 AMU. By calculating or adding both all these three values, we get the molecular mass of nitric acid. What is formula mass, students? In such cases is the sum of atomic masses of all the atoms present in one formula unit of a substance. For example, formula mass of sodium chloride is 58.5 AMU and calcium carbonate is 100 AMU. We can easily calculate the formula mass of potassium sulfate like this by calculating the atomic mass of potassium, atomic mass of sulfur, atomic mass of oxygen. By adding it, we will get the formula mass of potassium sulfate. Next, students, we have the topic of chemical species. First of all, look at the definition of ion. What is ion? Ion is an atom or group of atoms having some charge on it. So it has two types, cations and anions. What is cation? an atom or group of atoms having positive charge on it is called cation. The cations are formed when an atom lose electrons. जब भी कोई atom अपने electrons को lose करता है और उस पे plus का sign आ जाता है, charge आ जाता है, so it will show as a cation. For example, Na plus, K plus are the cations. On the other hand, what are the anions? An atom or a group of atoms that has negative charge on it is called anion. Anion is formed by gain or addition of electrons of an atom. जब भी atom कोई एक electron को gain करता है दूसरे atom से, it will become an anion and it will show the negative sign Cl minus and O2 minus. Following examples show the formation of an anion. Next, students, we have the difference between an atom and ion. The smallest particle of an element is atom. On the other hand, ion is the smallest unit of an ionic compound. Atoms cannot exist independently and can take part in a chemical reaction, and atoms are electrically neutral. In case of ions, it cannot exist independently and is surrounded by oppositely charged ions, and it has a net charge, either negative or positive, on it. Molecular ion. What is molecular ion? When a molecule loses or gains an electron, it forms a molecular ion. Hence, molecular ion or radical is a species having positive or negative charge on it. Like other ions, they can be cationic or molecular ions if they carry positive charge, or anionic molecular ions if they carry negative charge. Next, we have the difference between molecular and molecular ion. What is molecule? It is the smallest particle of an element or a compound which can exist independently and shows all the properties of that compound. On the other hand, molecular ion, it is formed by gain or lose of electrons by a molecule. Molecules are always neutral. In case of molecular ion, it can have negative or positive charge on it. Yes, molecule, it is formed by the combination of atoms and it is in stable unit. It is a stable unit. Molecular ion, it is a reactive species and it is formed by the ionization of a molecule. What are free radicals, students? Free radicals are the atoms or group of atoms possessing odd number of unpaired electrons. It is represented by putting dot over the symbol of an element like hydrogen dot, chlorine dot, H3, C dot. Free radicals are generated by homolytic equal breakage of the bond between two atoms when they observe heat and light. A free radical is extremely reactive species as it has the tendency to complete its octet. Here we have the difference between ions and free radicals. Ions are the compounds which bear some charge. Ions exist in solution or in crystal lattice form. Their formation is not affected by the presence of light. Free radicals are the atoms that have odd number of electrons. They can exist in solutions as well in air. They may form in the presence of light. Types of molecules. First of all, look at the definition of molecule. A molecule is formed by the chemical combination of atoms. It is the smallest unit of a substance. Yes, we know about it. Here we have different types of molecules depending upon the number of and types of atoms combining. If a molecule consisting of only one atom, it is called monatomic molecule. For example, helium, neon, argon. If a molecule consists of two atoms, it is called diatomic. For example, H2, O2, Cl2. If it consists of three atoms, it is called triatomic. For example, H2O, CO2. Yes. Next, a molecule containing same type of atoms, it is called homoatomic molecule. For example, H2O3, S8. And if a molecule consists of different kinds of atoms, it is called heteroatomic molecule. For example, CO2, H2O, and NH3. Next, students, we have the concepts of gram atomic mass, gram molecular mass, and gram formula mass. What is gram atomic mass? Yes, here we have the definitions. The atomic mass of an element expressed in grams. अगर हम atomic mass किसी भी element के atomic mass को grams में express करें, it is called the gram atomic mass or gram atom. It is also called a mole. Here we have the examples. Gram molecular mass, the molecular mass of an element or compound expressed in grams is called the gram molecular mass or gram molecule. It is also called a mole. 1 gram molecule of hydrogen is equal to 2.8 grams. It means 1 mole of hydrogen. 1 gram molecule of H2O water, which is 18.0 grams, it means 1 mole of water. Gram formula mass, the formula mass of an ionic compound expressed in grams is called gram formula mass or gram formula. This is also called 1 mole. For example, 1 gram formula of NaCl is 58.5 grams, which is 1 mole of sodium chloride. Next, what are Avogadro's numbers? Yes, Avogadro's numbers is a collection of 6.02 into 10 with power 23 particles. It is represented as Na. This is its value. So it is called the Avogadro's numbers. In simple words, 6.02 into 10 with power 23 particles are equal to 1 mole, as 12 eggs are equal to 1 dozen. So to understand the relationship between Avogadro's number and a mole of a substance, let us consider a few examples. Number 1, 6.02 into 10 with power 23 atoms of carbon are equivalent to 1 mole of carbon, and this value is also molecules of H2O are equivalent to 1 mole of water, and 6.02 into 10 with power 23 formula units of NaCl are equivalent to 1 mole of sodium chloride. So students, for further explanation about number of atoms in molecular compounds or number of ions in ionic compounds, let us discuss 2 examples. Number 1, 1 molecule of water is made up of 2 atoms of hydrogen and 1 atom of oxygen. 1 formula unit of sodium chloride consists of 1 sodium ion and 1 chloride ion. Next, we have the definition of a mole. It is a chemist's secret unit. Mole. A mole is defined as the amount mass of a substance that contains 6.02 into 10 with power 23 number of particles of atoms, molecules or formula units. Basically, it establishes a link between mass of a substance and number of particles as shown in summary of molecular calculations. It is abbreviated as MOL. Also, we can define mole as scientists have agreed that Avogadro's number of particles are present in 1 molecular mass of a substance. The quantitative definition of mole is the atomic mass, molecular mass or formula mass of a substance expressed in grams is called mole. Here we have the examples. Here we have the formula to find the number of moles, which is equal to known mass of a substance over molar mass of a substance, or mass of a substance is equal to number of moles into molar mass. So students, here we have this flow chart which represents that substance consists of elements, compounds, molecular mass. It is expressed in grams, gram molecular mass, yes, and 6.02 into 10 with power 23 molecules is equivalent to 1 mole. Also, formula mass in the end is equivalent to 1 mole. Atomic mass AMU in the end equals to 1 mole. So students, here we have some examples. Calculate the gram molecule, number of moles in 40 grams of H3PO4. Mass is given, which is 40 grams. Molecular mass of H3PO4 is 98 grams mole. By putting values in this above formula, we get the answer. Thus 40 grams will contain 0.408 grams molecule mole of H3PO4. Next, we have some chemical calculations. To find the number of moles, we must have known mass of a substance over molecular mass of a substance. Then calculate number of particles from the calculated number of moles with the help of the following equation. Number of particles is equal to number of moles into 10 into 6.02 into 10 with power 23. Next, we can find out the mole mass calculations by this formula. Number of moles is equal to known mass of a substance over molar mass of a substance. When we rearrange this equation to calculate mass of a substance from the number of moles of a substance, we get this. Mass of a substance in grams is equal to number of moles into molar mass in grams. How we can use this formula? Yes, here we have the example. you have a piece of coal, carbon weighing 9.8 grams, calculate the number of moles of a coal. So known mass of a substance is 9.8 and molar mass of carbon is 12. By dividing it, we get the answer, number of moles. Next, what is mole particle calculations? Here we have the formula. Given number of particles over Avocados numbers, we know about the value of Avocados numbers, which will be same in all these numerical type questions or examples. So we will rearrange it to find the number of particles, number of moles into 6.02 into 10 with power 23. So here we have the summary of molar calculations. So always remember, never calculate the number of particles from mass of a substance or vice versa. Always make calculations through moles. And for calculations of the number of atoms in molecular compounds and the number of ions in ionic compounds, first calculate the number of molecules or formula units and then calculate the number of atoms or ions. Next students, we have some interesting information. The molarity of the physical world. The nature of the physical world as perceived through men's senses has been investigated in depth. The biggest lesson we learned in 20th century is that chemistry has become central science. It leads to the discovery of every chemical reaction in any living or non-living organisms. Corpuscular nature of matter. In 1924, D. Broglie put forward the theory of dual nature of matter. Matter has both the properties of particles as well as waves. He explained the background of two ideas. He advocated that these two systems could not remain detached from each other by mathematical evidences. He proved that every moving object is attached with waves and every wave has a corpuscular nature as well. It formulated two bases to understand a corpuscular nature of matter. In the end, the work of different scientists at the same time handicap or promote the growth of science. Mole, a quantity, a computer containing with a speed of 10 million atoms a second would take 2 billion years to count 1 mole of atoms. If 1 mole of marbles were spread over the surface of the earth, our planet would be covered by a 3 miles thick layer of marbles. So students, all these are the very interesting facts about this chemistry and the topic mole. If a glass of water which contains about 10 moles of water has more water molecules than the grains of sand in Sahara Desert, which is the largest desert in the world. So students, this is all for today. Thank you. Allah Hafiz.